Hello class. Today we will be talking about capacitors. My name is Duran Arsenault.
I'm Mark David Waters Jr.
I'm Daniel Steele Jr.
And the person recording is David Lamont.
Hello. Okay, so first we will find, our goal is to find the CEQ and the Q total.
Since he didn't know the official name of what the CEQ and Q total was, CEQ is the equivalence capacitance of the circuit and Q total is the total charge of the circuit. Thank you.
Okay. So today we'll be using these formulas. For a series, capacitance or a series, we use 1 over CEQ equals 1 over C1 plus 1 over C2, etc. For parallel, you will find, for the CEQ and parallel, you just add them normally. So C1 plus C2. So the easiest thing to do for the circuit is to break it down. So you want to add these two first because they're in series. So it'd be 1 over 6 and 1 over 4, right? So you add those together, and that gives you 1 over CEQ. So you inverse it, and you get 12 over 5 microfarads. And since these two are in parallel, you just add these normally. So it's 3 plus 12 over 5, that gives you 27 microfarad. And since there's no capacitor right here, we could just move this capacitor that we just add together to the spot, like what you did. And since these are series, this capacitor, this capacitor, this capacitor. So it's 1 over 2 plus 1 over 5 plus 5 over 27 microfarads. And that gives you 270 over 239 microfarads. Okay. Now, see how simple this is so far? Now we add these two since they're in series. So it's 1 over 1 plus 1 over 3. So that gives you 4 over 3. But you inverse it, so it's 3 over 4 microfarads.
So to get your CEQ, the equivalence capacitance of the circuit, you would add 304 plus 279 over 239, and you would get 1,797 over 956 microfarads. So right here, CEQ is equal to 1,797 over 956 microfarads, which is congruent to 1.88 microfarads. And to get the total charge, you would do Q equals CV. So the voltage, which is 5, and your CEQ, which is 1.88. So 5 times 1.88 would get you 9.4 microcoulombs.
We just had a review over capacitors. Now we're going to move over to Ohm's law, which we're going to be finding.
We'll be finding REQ, which is equivalent resistance of the circuit, and I total, which is the total current of the circuit.
Yes, that's what my classmate just explained. So we're going to start with making these resistors easier to work with because you need to combine them all to parallel and series circuits or resistors. So first we're going to start with the series resistor, which is 6 plus 4, which is going to give you 10 for that resistor. Then we're going to move over to this set of resistors, which is in parallel. So it's going to be 1 over 3 plus 1 over 10, which is going to give you 30 over 13. Once you inverse it, you have to inverse it. So now we're going to add these 3 resistors together because it's not parallel because it's all on the same wire. So we're going to start with 2 plus 5, which is 7, and then 7 plus 30 over 13, which is going to give you 121 over 13. Now we're going to move to this set of resistors, which is also in series, so that's just 1 plus 4. And then we're going to move to our final set, which is in parallel resistors. So it's going to be, you have to inverse this back, so it's going to be 13 over 121 plus 1 over 4, which is going to give you 484 over 173 once you inverse it again. And we move on to that.
And that gives us our equivalence resistance, which 484 over 173 ohms is also equal to about 2.8 ohms. So then we find our total current, which we use the equation I equals V over R. Our voltage for the circuit was 5 volts, and so we use our REQ, which is 2.8 ohms, and that gives us 1.79 amps.